Hi guys, welcome to web scraping and mapping dam levels in Python. In this course, we're going to be covering a couple of topics ranging from mapping, web scraping, data visualization, ETL, and databases. So let's take a deeper dive into each and every one of these topics that we're going to be covering in this course. So the first one is mapping. So as a mapping library, we're going to be using something called leaflet.js. So leaflet.js is a JavaScript library that is used for building interactive maps. The second topic that we'll be hitting is called web scraping. So web scraping is a form of data mining which involves extracting data from a website. Another word for it is called web harvesting. The third topic that we'll be looking at is data visualization. Data visualization is the process of visualizing data by displaying it in graphs. So as a visualization library, we're going to be using chart.js. So chart.js is a JavaScript library as well, used for building interactive graphs. The next topic that we'll be tackling is ETL. So ETL stands for extract, transform, and load. So ETL is the process of extracting data from a variety of sources, cleaning and transforming that data, and lastly loading that data into a target table or a flat file. The last topic that we'll be hitting is databases. So as a database, we're going to be using PostgreSQL with PostgIS extensions. So PostgreSQL is where our data will reside in the long term. Okay, so let's take a look at the application. So this is a WebGIS application. Okay, so what this does is it maps the 6 main dams that we depend on in Cape Town as a source for our residential water. Okay, so these dams supply our water for basically all suburbs in this region. Okay, so firstly, I want you to notice the size of the circle markers. So if I click on one, a pop-up will show up displaying the name of the dam. So this dam is called the Berg River. So this is the Berg River Dam. This dam, for instance, is the Waterskloof Dam. So as you can see, it's plotted in the form of a bubble chart. And as you know, a bubble chart works in this manner, that each bubble, right, varies in size. So if the size of the bubble is smaller compared to the rest of the bubbles, it means that the value of that bubble is less. And if the bubble seems to be larger than most of the other bubbles, then the value of that bubble is larger. So each and every dam's value is in percentages. So we are going to be displaying the volume of water that is stored currently in that dam. So this data resides in the Western Cape government's website. So they publish this data on a weekly basis if you're lucky. Sometimes it takes a little bit longer, it gets a bit delayed, and you might end up getting it 2 weeks later, but it's reasonably current. So we're not using historical data that we downloaded that got recorded a couple of years ago. This is actual current data that we use in order to see how much water we currently have in our dams. Okay, so if we take a look at our KPI here, so what this does is that it displays the mean, right, the average water stored in this entire region, right? So what it does is that it takes each percentage value of water available in the 6 main dams of Cape Town, and then it works out the mean, right, meaning the average of water that we have available in the region. So right now we are in the green. We have 64% of water in the region, right? Which is okay, right? And as you can see next to the value, we have a green arrow pointing up. So this is a KPI that indicates that we are not in danger of a drought. Okay, so we still have a reasonable amount of water in our dams overall in this region specifically. So once we hit a value of 50% and lower, actually lower than 50%, 49% and lower, the arrow will point downwards and it will turn red. So this logic is built into this application. Okay, so another thing that we can do is, or you can do if you expand on this application, is you can add a notification for yourself for when the average water that we have left in the region is under 50%. Then perhaps you could send yourself an email notification or an SMS notification telling us or warning us that we are in the danger zone and we are running out of water in our dams. Okay, so let's take a look at the data. Okay, so as you can see, each dam is color coded. Okay, so each color is unique for that specific dam. And if we look at our donut chart, we can see each slice has a different color, which correspond to the color of the circle marker, right, which corresponds to the dam. So we can see the Berg River Dam is in a dark blue color, and in the donut we can see the Berg River Dam is also in a dark blue color, and the value of the percentage of water that is left in the dam currently is 78, right? So we can see the percentage data value as we hover over the slice that corresponds to that dam. So in the donut chart, we're visualizing the dam levels for this week. So this is the amount of water that we have stored currently this week. Okay, and below you will see what you call a multi-bar bar chart. So multi-bar bar charts are used for comparison. Okay, so here we'll be comparing this week's values versus last week's value versus last year's value. Okay, so let's take a look at let's compare this week and last year. So as we can see, we are looking pretty good in terms of the amount of water that is stored in our dams. So which is true because we have been receiving a fair amount of rainfall, which then filled up our dams. Whereas before, as you can see, last year we were busy recovering from a drought scare, okay, which is okay considering how it used to be. We were literally running dry, okay, and it is evident in the Waterskloof Dam. As you can see, last year the last recorded percentage value of water was 11%. So it was quite scary. We could see when we actually looked at the images of the dam, there were fish laying dead and dry because there was hardly any water for them to live in. Okay, and if we just look at last year, we can see that it's quite scary, right? But also we were busy recovering from that drought scare, so you can see more and more rainfall occurred and the dam started filling up. Okay, and if we look at this week versus last week, we can see that we kind of are using up more water, right? Or we didn't receive as much rainfall, right? But we're still in a decent range compared to last year, okay? So I would say we are looking pretty good. And the Waterskloof Dam, which was at 11% last year, is now at 44%, which is pretty good. And you can see the size of the bubble or the circle marker shows you that the Waterskloof Dam has the least amount of water stored. This could either be that the dam is smaller than the Berg River Dam, for instance, or it could be that the people or the people residing near the dam who are using the dam, the dam's water, are very disciplined in the manner in which they use and save water. So that could also be an indication of why the Berg River is has more water stored compared to the Waterskloof Dam. So there's a couple of reasons that you yourself could try and analyze and figure out. And yeah, so the back end of this application is obviously Python, and the web framework that we'll be using is Django. So I hope you guys will enjoy this course as much as I enjoy taking it for myself. While I was building this application, I have learned a lot, and I've also learned how to combine the latest technologies. This application is utilizing the latest technology, so you don't have to worry about outdated tools that we'll be using. So whatever you learn from this, you will be able to apply right now. In fact, you might even be ahead of some of the members of your team, right? And you can also take the source code and build on that, or use it for applications that you'll be building for yourself. So I hope you guys will really enjoy this course. I really enjoyed it, and I mean, web scraping is a crucial manner of obtaining data where it's almost impossible to obtain it any other way, and it's a very smart way, right? And it can be automated. Like, for instance, we collect data once a week, right? So all we need to do is just keep the application running, and then on the day that the Western Cape government is supposed to be publishing the dam data, it will be automatically fetched by the web crawler and displayed. And the mean, the average water available in the region, will automatically be calculated autonomously. And you'll be learning how to do all of that in this course, right? So I'll be just showing you guys a bit of how this tile displays these dams. I'll also be showing you how to use this web map service to obtain this tile and use it as a base map in your applications. Okay, so this is the upper and lower, I think Steenbras Dam upper, Steenbras Dam lower. And as part of the ETL, I'll be showing you how to join pandas data frames in order to get the GPS coordinates, right? So all of that you'll be learning in this course. So thank you for your time. Thanks for watching this, and I hope you guys will have a blast, right? And I hope you'll be able to complete this without making too much mistakes. And if you need help, you have my email available. I do answer all queries as best as my knowledge. I also have the source code if you want to just, instead of following along, just copying and pasting the boring stuff like the tedious stuff like the front end and the styling, etc. And also make sure you have a decent internet connection in order to kind of stream this web map service that will allow us to display the base map. So as you can see, my internet connection is not that great at the moment, so it's kind of laggy. And yeah, thank you very much, guys. Enjoy. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, I showed you guys how the application will look that you'll be building, and in this video, we'll start with the building of that application step by step. So the first thing that we're going to do is we're going to be installing PostgreSQL. So let's first open up our terminal with Control Alt and T. Once the terminal is open, I want to switch to my root user so that when I install third-party software, I won't run into any issues. Okay, so the first thing that we're going to do is we're going to add an app repository and key for PostgreSQL. Okay, so if we see the OK message, it means that these were added successfully. And the next thing that we're going to do is we're going to update our repositories. Okay, once that is done, we're going to be installing PostgreSQL 9.6. Y for yes. Okay, so that looks like it went fine. The next thing that we're going to do is we are going to check which version of PostgreSQL is installed so that we can verify that our installation was successful. So as you can see, we are currently running PostgreSQL 9.6, so our installation was successful. And the next thing that we're going to do is we're going to add an app repository for Ubuntu GIS. Press enter. Okay, so we see the OK message. It means it was added successfully. And the next thing that we're going to do is we're going to update our repository. Okay, so once that is done, the next step that we're going to do is we are going to be installing PostgreSQL version 2.3. Y for yes. So this specific version of PostgreSQL is compatible with PostgreSQL 9.6. Okay, looking good so far. And the last thing that we're going to be installing is PG routing. So this is PG routing for PostgreSQL 9.6. Y for yes. Okay, so this marks the end of this video. Thank you guys for tuning in, and I'll see you in the next one. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we installed PostgreSQL and PostGIS, and in this video, we will be creating the database for the application. So if you haven't done so already, open up the terminal with Control Alt and T and then switch to the root user. And once you've done that, we are going to enter the command line interface in full admin mode for the user PostgreSQL. Or Postgres rather. The first thing that we're going to do is we're going to create the database. I will call it CPT dams. And then the next thing that we're going to do is we are going to create a user for that database. And we are going to call, we can call it anything. I'll call it CPT user. And then as a password, I'm just going to use Postgres. Okay, once that is done, the next thing to do is to enter into that database. from the PSQL shell. Okay, once we have entered into the database using the PSQL shell, we are going to add GIS extensions to that database. The first extension that we're going to add is PostgreSQL. Okay, and the next extension will be PostgreSQL topology. Okay, it seems like a typo. Okay, and now after we've done that, we are going to exit, quit the PSQL shell with \q, and then exit this user, and then we're done. Okay, so that will be it for this video, and stay tuned for the next one. Thank you. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we installed and configured PostgreSQL and PostgreSQL, and we also created a database and a user for our application. In this video, we'll be installing some essential development tools for Python, and we will also create our virtual environment and install Django. If you haven't done so already, open up your terminal with Ctrl+Alt and T, and then we are going to switch over to our root user. Once that is done, the first thing that we're going to do is we are going to check if Python 3 is installed by checking for the version of Python 3. It's Python 3 -- version. So as you can see, I have Python 3.5 installed on my machine. So this is the default installation version of Python 3 that you get when you install Ubuntu Linux. And once that is done, we are going to install the Python 3 pip installer. So this installs third-party libraries that will help enrich our applications. So that will be sudo apt get install Python 3 pip y for yes. Once that is done, we are now going to install some essential development tools for Python. I'm just going to copy over this command. Please do note that I'll make these available for you guys to use so that you don't have to type out everything. Okay, so once that is done, we are going to install Python 3 venv. So venv will allow us to create a virtual environment for our application, so that when we deploy our application elsewhere, we won't have to reinstall the third-party libraries that we were using to develop that application. So it will ship the third-party libraries with the application inside a virtual environment. Okay, so that will be sudo apt get install Python 3 venv. Okay, so once that is done, we are going to change into our desktop. Once we're in here, we are going to create a directory for this project that we'll be working on. So it's make dir. I'm going to call it dam levels course. You can call it whatever you want, dam levels tutorial or whatever. Okay, so once that has been created, you can see the desktop icon popping up. Okay, and then the next thing that we're going to do is we are going to change our directory into that folder that we have just created. So once we are in here, we are going to create our project folder, and we are going to call that dam levels. Make dir dam levels. So this is the name of our project and where our project will reside. Okay, then we change into that directory. Once we are in there, the next thing that we're going to do is we are going to create our virtual environment. So that's py-vn, and then I'm going to call it vn. You can call it whatever you want. I'm just going to call mine vn. Okay, so our virtual environment is created for us. So now the next thing that we're going to do is we are going to activate our virtual environment. So that is source vn bin activate. So once our virtual environment has been activated, it means that if we install our third-party libraries or packages, we don't have to specify the Python version, because it installs the same package for both Python 2, 2.7 and for Python 3. So you will also notice that the prefix here has vn in brackets. So that means that our virtual environment has been activated and that we are now working within our virtual environment. And if we say deactivate, we can deactivate our virtual environment. If I spelled that right. As you can see, that prefix is gone. So now we're going to activate it again. Source vn bin activate. Okay, so while we are still inside our virtual environment, the next thing that we are going to do is we are going to install Django toolbelt, which will allow us to install Django as well as any other libraries that support Django development. So that is pip install Django toolbelt. Okay, great. So once that has been installed, we are now going to create a requirements.txt file with a list of our Python external dependencies and libraries. So that's pip freeze requirements.txt. You can call it anything you want. This is just the name of the file where we will list our third-party libraries, so that when we want to install that again, we won't have to install, we won't have to use the pip package manager to install each and every one of those libraries independently, but we can just run the pip install on this text file here, and it will install all our libraries that we've specified inside the text file, as you will see right now. So pip freeze to create that file. As you can see, the file is here, and now we will check the contents of that file. Cat requirements.txt, and as you can see, here are all our third-party libraries that we need for our Django development, including Django itself, as well as GUnicorn and CyclePG2, which are the essential ones. And that's about it. Thanks for tuning in, and I will see you guys in the next video. Thank you. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we installed and configured PostgreSQL and PostgIS, and we also created a database and a user for our application. In this video, we'll be installing some essential development tools for Python, and we will also create our virtual environment and install Django. If you haven't done so already, open up your terminal with Control Alt and T, and then we are going to switch over to our root user. Once that is done, the first thing that we're going to do is we are going to check if Python 3 is installed by checking for the version of Python 3. It's Python 3 -- version. So as you can see, I have Python 3.5 installed on my machine. So this is the default installation version of Python 3 that you get when you install Ubuntu Linux. And once that is done, we are going to install the Python 3 pip installer. So this installs third-party libraries that will help enrich our applications. So that will be sudo apt get install Python 3 pip y for yes. Once that is done, we are now going to install some essential development tools for Python. I'm just going to copy over this command. Please do note that I'll make these available for you guys to use so that you don't have to type out everything. Okay, so once that is done, we are going to install Python 3 venv. So venv will allow us to create a virtual environment for our application, so that when we deploy our application elsewhere, we won't have to reinstall the third-party libraries that we were using to develop that application. So it will ship the third-party libraries with the application inside a virtual environment. Okay, so that will be sudo apt get install Python 3 venv. Okay, so once that is done, we are going to change into our desktop. Once we're in here, we are going to create a directory for this project that we'll be working on. So it's make dir. I'm going to call it dam levels course. You can call it whatever you want, dam levels tutorial or whatever. Okay, so once that has been created, you can see the desktop icon popping up. Okay, and then the next thing that we're going to do is we are going to change our directory into that folder that we have just created. So once we are in here, we are going to create our project folder, and we are going to call that dam levels. Make dir dam levels. So this is the name of our project and where our project will reside. Okay, then we change into that directory. Once we are in there, the next thing that we're going to do is we are going to create our virtual environment. So that's pyvenv, and then I'm going to call it venv. You can call it whatever you want. I'm just going to call mine venv. Okay, so our virtual environment is created for us. So now the next thing that we're going to do is we are going to activate our virtual environment. So that is source venv bin activate. So once our virtual environment has been activated, it means that if we install our third-party libraries or packages, we don't have to specify the Python version, because it installs the same package for both Python 2, 2.7 and for Python 3. So you will also notice that the prefix here has venv in brackets. So that means that our virtual environment has been activated, and that we are now working within our virtual environment, and if we say deactivate, we can deactivate our virtual environment, if I spelled that right. As you can see, that prefix is gone, so now we're going to activate it again. Source VN bin activate. Okay, so while we are still inside our virtual environment, the next thing that we are going to do is we are going to install Django tool belt, which will allow us to install Django as well as any other libraries that support Django development. So that is pip install Django tool belt. Okay, great. So once that has been installed, we are now going to create a requirements.txt file with a list of our Python external dependencies and libraries. So that's pip freeze requirements.txt. You can call it anything you want. This is just the name of the file where we will list our third-party libraries, so that when we want to install that again, we won't have to install, we won't have to use the pip package manager to install each and every one of those libraries independently, but we can just run the pip install on this text file here, and it will install all our libraries that we've specified inside the text file, as you will see right now. So pip freeze to create that file. As you can see, the file is here, and now we will check the contents of that file. Cat requirements.txt, and as you can see, here are all our third-party libraries that we need for our Django development, including Django itself, as well as GUnicorn and CyclePG2, which are the essential ones. And that's about it. Thanks for tuning in, and I will see you guys in the next video. Thank you. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we downloaded and installed the Atom IDE. We also installed our terminal inside the IDE and verified that it was functioning. In this video, we'll be creating our Django skeleton application, which is the base of our application, and then we will open it in our IDE and run it to verify that Django is installed successfully. So the first thing that we're going to do is we are going to open up our Atom IDE from the start menu. Okay, so once that is open, we are going to open up the terminal in the right pane. So it's packages term 3. Okay, so once that is open, we are going to switch to our root user. Okay, once that is done, I'm going to navigate to my dam levels course folder on my desktop. Okay, so once I'm in there, I'm going to activate my virtual environment. So I'm first going to go to the dam levels project folder and then activate my virtual environment. Okay, once that is done, the next thing that I'm going to do now is I'm going to create the dam levels project using Django admin. So it's Django admin.py start project dam levels and then space and period. Okay, so once that has been created, we are going to verify that our files were created for us, as well as our manage.py file. As you can see, our project is created and our manage.py file is created. So let's go into that project file and see what's in there. Okay, so as you can see, our settings.py file has been created for us. So now we change back. Okay, and the next thing that we're going to do is we are going to create our DAM levels app. So we have our DAM levels project, which includes all our project files as well as manage.py, and then we have our DAM levels app, which includes our files for our app, which are things like views.py or admin.py or models.py, those type of files. So in order to do that, we are going to say Python, and we're going to use manage.py now, which we have created. Manage.py start app, and we're going to call it DAM levels app. Okay, so we verify if our app files were created for us. And as you can see, the DAM levels app folder is here, and let's check if there's files inside. Okay, so as you can see, our admin.py, our views, and our models.py files, and the rest of our other app files have been created for us. Okay, now the next thing that we're going to do is we are going to change the permissions of the DAM levels course folder, as well as the subfolders and files inside, to make sure that we can open it up in our IDE. So let's go back to the desktop level. Okay, so now that we're in our desktop, we are going to run sudo chmod 777. So we are allowing read, write, and execute full permissions on this folder for the public. It is not the safest way to do things, but in order for us to not run into permission issues while we are doing this course, it doesn't really matter. Okay, so it's R for recursively, and then the name of the folder, which is DAM levels course. Okay, so once we have done that, we should now be able to make changes to this folder without running into permissions issues. So now we are going to open the project in our Atom IDE. So we go to File, Add Project Folder, and then Desktop, double click on DAM Levels course, click on DAM Levels, and click OK. Right. So as you can see, our project has been imported into our IDE. So we have our DAM levels app, and we have our DAM levels project files. Right, here they are. We have our manage.py and our requirements.txt. Okay, so our project has been imported successfully. So now the next thing that we are going to do is we are going to start the Django server. So let's go back into our project folder. Okay, so now that we're in order to start our server, we are going to say Python manage.py run server. Okay, so our server is running, and it has been started on port 8000 on this is the IP for localhost. So now let's open up our web browser. And let's navigate to localhost port 8000, where our application is busy running. And as you can see, our Django project has been set up and installed successfully. So it means that our application is running without any issues. If you see this page, so it says the install worked successfully, congratulations. So that will be it for this video. Thank you guys for tuning in. I'll see you in the next one. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we created our skeleton application. We also changed the permissions of the dam levels course folder and its subfolders and files, which then allowed us to open up our project in our IDE. In this video, we'll be adding our spatial database to our project by editing the settings.py file. So if you haven't done so already, open up your IDE from the start menu. And once that's open, we are going to open up our terminal in the right pane. So once that is open, I'm going to switch over to the root user. Okay, and then the next thing that we're going to do is we are going to activate our virtual environment. So once that is done, the next thing that we're going to do is we are going to install Django leaflet. So it's pip install Django leaflet. So Django leaflet will be the GIS library that we will be using to display our maps and call our geo services. And once that is done, the next thing that we're going to do is we are going to install GeoJSON. So GeoJSON will be the serialization library that we will be using to serialize our GIS data and then pass it to and from the front end using Ajax. Okay, and then once that is done, let's go to our settings.py file. So we can close this for now. Okay, and let's locate our settings.py file. Okay, once that's done, let us go to our list of installed apps. Okay, so we are first going to add an app called Django Contrib.gis. And then the next app that we're going to add is our application. So our application's app is called Dam Levels app. Okay, so once we've done that, the next thing that we're going to do is we are going to edit our database configuration. Here we are. So the first thing that we're going to be doing is changing our engine property to point to PostgreSQL instead of SQLite 3. Okay, and then the next thing that I'm going to do is I'm going to add the name of our database as well as our user. So we said that the name of our database will be CPT dams with an S. and then we said that our user would be cpt user. So that is our database user for cpt dams. And then the next thing that we're going to do is add a property for the password. And then I said I will make mine Postgres. And then the next thing that we're going to add is our host. So our database is running locally on our machine. So the host name will be localhost. Okay. So once that is done, the next thing that we're going to do is we are going to run the Python migrate command to apply changes made to this file, especially our database. So let's open up our terminal again in the right pane. Change to the root user. Activate our virtual environment. Once that is done, I'm going to run the migrate command, python manage.py migrate. Okay, so our migration has been run, and because I've already worked on my database, you'll see that it will say no migrations to apply, but with you guys you will see an OK message, right, while it applies the migration. And then the next thing that we are going to do is we are going to create a super user for our Django admin console. So it's python manage.py create super user. Okay, then you have to enter a username. I'll just call mine root. Okay, so that's already taken. I'll just call it dams. The email, I will leave it blank. The password, I'll just call it Postgres. Okay, so our super user has been created successfully, and now we are going to test that by first running our server. So it's python manage.py run server. Okay, so our server is running on localhost port 8000. So let's open up our web browser. And now instead of opening up our application, which is running on port 8000, we are going to open up the Django admin console by saying /admin. Okay, so now let's verify that our super user credentials are working. So we said that the username was dams, and the password I said would be Postgres. And as you can see, I can log in with my created super user. And now let's click on users to verify that the account is there. And as you can see, my dams account has been created for me and that it's active. So that's about it for this video. Thank you guys for tuning in, and I'll see you in the next one. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we added our spatial database to our project by editing the settings.py file. We also installed two third-party libraries called Django Leaflet and GeoJSON using the pip installer. In this video, we will be creating our model in the models.py file, and this model will be the table where our data will be stored. So if you haven't done so already, open up your IDE from the start menu. And once it is open, click on the models.py file. And once we have that open, the first thing that we are going to do is we are going to remove this first import statement over here. The reason why we are going to do that is because this import statement imports a default Django model, and we will not be using that. So we will be creating a model for a spatial database. So we need to import a GIS model instead. So let us comment out this import statement and then add from django.contrib.gis.db import models. Okay, so the next thing that we are going to do is we are going to create a class for our model. So the class will represent the schema of our table, and the table name in the database will be the same name as the class name by default. Okay, so let us add the code for our class. So that will be class, and we are going to call it dam levels. And then we are going to tell it to inherit from models.model. Okay, once we have done that, the next thing that we are going to do is add the fields for our class, which will be the fields for our table. So the first field that we will add is the ID field, and that will be of type integer. So it will be an integer field, and we will set this field to the primary key. So primary key equals true. The next field that we will add is the name of the dams, which is the dam field. So this will store the name of each dam, and this will be of type char. So we're going to make this a char field, and we will set the max length of this field to 100. The next field that we will add is the dam level value field, which we will call this week. So that will be the dam level value for this week. And this will be of type decimal. And we will set its precision to maximum digits of 5, and we will allow 2 decimal places. Okay, and the next field will be the same, but it will be the dam level value for last week, and it will be the same data type and precision. So we will just copy that one, and then we are going to do the same for the field that we will call last year. So this will be the dam level value for last year. And again, we will copy this. Okay, the reason why we are making these decimal fields is because they are quantifiable values. We are going to do calculations with them. So in order to have better accuracy in your calculations, it is better to use a decimal than an integer. So the next field that we will add will actually create a date for when we insert data into our table. So it will then use the current date time of when the record was inserted. So that will be like our log date. And we will call this creation date. So it is the date when this specific record that will be inserted was created. And this will be of type date time. So it will be a date time field. And the next field will store our GPS coordinates, our latitude and longitude value. And we will call this field geo. And it will be of type point field. Okay. And the next thing that we will add is a field that will allow us to group each record. So each record will be grouped by DAM name. So if we open up our Django admin console and we click in our table, we will see that each record that will be listed will be named by a DAM name. So each record will be grouped basically by DAM name. Okay, so in order to achieve this, we say define str self return the field that we want to group by, which is self.dam. Okay, and now we are going to add the alias name of our class or our model, and we will leave that as the same name as our class. So class meta verbose name plural equals dam levels. Okay, so now we have successfully added our model, which we will use to store our data that we will scrape. And that will be it for this video. Thank you guys for tuning in, and I'll see you in the next one. Hi guys, welcome back to web scraping and mapping dam levels in Python. In the previous video, we added our model to the models.py file, and in this video, we will start to write the code that will scrape our data from a website. So the first thing that we need to do, if you haven't done so already, is to open up your IDE from the start menu. Once that is done, we are going to open up our terminal in the right pane. Right, and then once that is done, we are going to switch over to our root user. Okay, and then the next thing that we are going to do is activate our virtual environment. Once we've activated our virtual environment, we are going to apply the changes that we've made to our model in the previous video. So we are going to run two commands, make migrations and migrate. So let's start with the one, Python manage.py make migrations. Okay, and as you can see, it says our migration was made, created the model called dam levels, and then the next command that we're going to run is migrate. Okay, so as you can see, we are getting our OK message, which means that the migrations have been run successfully. And now the next thing that we are going to do is we are going to install two libraries, the one which is called pandas and the other one is called Beautiful Soup 4. So Beautiful Soup 4 is the library that we are going to use to write our scraping code, and pandas is the library that we are going to use to do our ETL, which is extract the data, transform it, and then load it into our database. So let's start with pandas. pip install pandas. Okay, once that is installed, the next library that we are going to install is Beautiful Soup 4. Pip install Beautiful Soup 4. Okay, so once we have done that, we are going to close the terminal for now, deactivate our virtual environment, and then exit. And then now we are going to go to our settings.py file, and then we are going to change something in the list of installed apps. So let's go there. So we are going to add leaflet to our list of installed apps. Okay, once that is done, we are now going to open up our admin.py file. Let's first save with Control S, and then let's open up our admin.py file. So now we are going to start writing the code that will scrape the data from the website. Let's start with our import statements. The first one that we are going to import is the point class. So it's from django.contrib.gis.geos import point. The next one that we are going to import is for our creation date field, which is the date time library. So it's from date time import date time. Okay, and then the next one that we are going to import is leaflet.js. So from the leaflet app that we have just added, leaflet.admin import leaflet.geoadmin. Okay, and then now we are going to import pandas. So from, actually it's import pandas as PD. So instead of writing out pandas, we are going to use the abbreviation PD. And then we are going to import the requests library, which is going to help us get or download our HTML page when we enter the URL for our website we'll be scraping from. So it's request, and then we are now going to add our model that we have created in the previous video. So it's from dam levels app dot models import dam levels. And then lastly, we are going to import Beautiful Soup. So it's from BS4 import Beautiful Soup. Okay, so once that is done, we are now going to register our model. So we create a class called dam levels admin, and then we are going to pass it a leaflet geoadmin. We're saying inherit from leaflet geoadmin, and then pass. And now we are now going to register it by saying admin.site.register dam levels, and dam levels admin. Okay, so now the first thing that we are going to do is we are going to request the URL that points us to the website that we'll be scraping from and store it in a page, right? So we declare page and we say equal requests.get. So this will download our web page from using the URL. So I'll copy over the URL that we are going to use and that we are going to be scraping from. There it is. So it's going to get this page and store it in that object or that variable which we have created, which is now going to be a page object. So now let's open up our web browser and go to this URL. Paste it in there. And as you can see, here is our web page and this is the data that we want to scrape. So now the first thing that we are going to do is we are going to take a look at this table right here and then look at its properties or inspect its HTML code. So we're going to click on the dam field, right click and then click on inspect. Okay, so here is the HTML code for this web page, and as you can see, here is the dam, which is written in a level 3 HTML heading, and it is part of the first row. So if we click on that, we can see that each and every one of these are the rows, right? So we have the first row and the last row, and each row is stored inside a table body. So we want this table right here. And as you can see, notice the attributes of this table element. It says align center and border equals 4. So the table doesn't necessarily have a ID, so we can't use the ID to pinpoint this exact table while we're scraping. So we are going to have to use these attributes as well to tell us, okay, this is the table that we want, because as you can see, there is another table here. So if we just search for the table using Beautiful Soup, we wouldn't know which one to take. So as you can see, the attributes here are different to this table. So we're going to use these attributes to uniquely identify this table that we are looking for. Okay, so if we click on one row, so this is one cell, the first cell of the first row. Okay, and then if we open up the second cell, we can see river, and the third one photo, and so on. Right, so these are going to be our fields for our table. We are going to use these cells to get our values from. And then the next thing that you should notice is our rows. So this will be the rows that we'll be looping through, and we'll fetch each and every one. Right, so now you have a bit of an idea of what we are looking for. So this is the most important one. We're looking for this whole table, right? And then what we'll do is we'll perform ETL by removing some of the elements that we don't want, like this total right here and this bottom row and the photo field, etc. So you're going to transform this table into a table that we can use for our application. Okay, so now let us go back to our IDE. So once we've got the page, Now the next thing that we are going to do is we are going to create a beautiful soup object using that page. Okay, and then pass it that page, and then we are going to use the HTML parser of the beautiful soup object. So we create a soup variable, and then we are going to create a beautiful soup object and then feed it the page which we have gotten from this URL dot content, and then we are going to use the HTML parser of the beautiful soup object. You can also use an XML parser, but seeing that we have HTML code, we are going to use the HTML parser. Okay, and now the next thing that we are going to do is we are going to get the table container with the DAM data that we need, which we saw. Okay, so now we are going to use the find method of the beautiful soup object, which will allow us to search for the table that we want. So we are going to create a container for our table, and we're going to call it DAM data container. Equals soup dot find, and then we said that we're looking for a table element. Not only that, but the table element also has attributes called align center, and if we go back, align center and border equals 4. Border equals 4. Okay, so now we are going to test and see if it managed to get the correct table that we wanted by printing this container. So we are going to print DAM data container and then see what we get when we run this application. Okay, so let's open up our terminal again in the right pane. Switch to the root user, activate the virtual environment, and then run the server, python manage.py run server, and we should be able to see our code printed right here. Okay, so it appears that we had to pip install the request library as well. Okay, so Control C and then pip install. Let me first clear this. Pip install requests. I thought that it was actually included in the standard Python library, but it seems like it's an external library that we need to install. Okay. Once that has been installed, let us try again. Pip python manage.py run server. Okay, so as you can see, our table has been found. So we have found the right table using our find method from the beautiful soup object. And this is the table that we're looking to scrape. Table align center border equals 4. And as you can see, we have the first row. And we have our fields, dam, river, photo, this week, last week, and last year. And we have the next row containing our actual data, the Berg River, and its data values for this week, last week, and last year. Okay, So that looks good. This is exactly what we are looking for. So now we are going to close this for now. Control C to cancel the server. Deactivate the virtual environment. And clear. So we have our table now. And now the next thing that we are going to do is we are going to first write an if statement to check if data actually exists, if that table is there on the website, because sometimes it disappears and the application will generate an error if it can't find that table. So now we first specify that if the DAM data container is not none, right? So if it can't find this, it will return a null, which is a none in Python. And now we are saying if the container is not none. So if it finds the table, then run the following code that we are going to write. The first thing that we are going to do is we are going to get the rows of our table. So now we're using our container, which we stored our table that we found in, and we can uncomment this along. We're saying stored in a variable called table rows equals dam data container dot find all table rows. Okay, so if we go back here, you'll see these are our table rows. So it's gonna find all of these rows and then store it in this variable called table rows. Okay, once we have done that, let us print these table rows and see if it actually found them when it used the find all method of beautiful soup. Okay, so table row, rows with an S, is what we are going to print. So we open up the terminal again. Maybe we should leave it open, but there's not enough space. In the right pane, and then switch to the root user. Activate the virtual environment. Run the server. Okay, so now, as you can see, it has stored our table rows in a list. So this is the opening bracket right here of the list, and then as you can see, this is the first element, this table row, and there's a comma for the next element, starting at this table row, ending at that table row, and that's the comma for the next element, and so on up until the closing brace of the list. Okay, so it found our table rows and stored it in a list. And now the next thing that we are going to do is we are going to create an empty list, and then we are going to strip all the text, right? Because sometimes what happens is that these data values usually have a hash sign, which I'm not sure what it means in front of it, but I will usually strip that. So I strip all text in each row. So let us, I'm wondering if I should close this terminal or not, since we're going to be printing more Okay, so let us just clear this, deactivate and exit, and instead we are going to use our terminal. So it's Control Alt and T, make it a bit smaller, and then it's sudo bash to switch over to our root user. And then let's locate our project, which is at desktop, dam levels course, dam levels, and now let's activate our virtual environment, source vn bin activate. So once that is done, we can now run our Python server, python manage.py run server. Okay, so here we have our list of rows again. So now we, instead of opening and closing the IDE's terminal, we can use our Linux terminal instead, and we can actually keep it running. Okay, so we've gotten all our table rows and we've printed it, and I will end this video here, and I'll see you guys in the next one. Thank you.